Hi hackers, welcome back to our game hacking series. I would like to thank Buckrout for sponsoring this series. On Buckrout platform, you can expect to find best opportunities to make money, advance your skill, and build a cybersecurity community. In this video, we'll explore different ways and techniques of game hacking. We'll also solve another quest of the game using binary patching and DLL injection. Before getting started, let's take a quick look at the recap of our previous video. In the previous video, we looked into some methods of finding important values, memory addresses, manipulating the in-game values, and game logic. We've already seen memory manipulation and learned the ropes of cheat engine. But now let's take things a step further and explore the fascinating world of binary patching and DLL injection. To get started on this adventure, you'll need a few new tools apart from our initial setup. That is Visual Studio for compiling DLLs, Hex Editor for editing DLLs, and for injecting DLLs, we will be using Cheat Engine only. Now without wasting any more time, let's jump into the game and analyze the DLL file on Ghidra. Have you ever wondered that how modded games come into existence? Well, today we'll show you how to edit the game itself and unlock a new world of possibilities. So let me just open Ghidra. As you guys know, we have already opened Ghidra in the previous part and we have already created a new project. So we can just open the DLL file by double clicking it. In parallel, let's open the game as well. To begin our journey into binary patching, we'll first look at a static variable. Let's focus on our player's sprinting feature, as a speed hack will help us in solving other quests and exploring the game world efficiently. Let's use Ghidra to search for sprint within the game logic. So I'll just click on search and I'll search for sprint to see if we can permanently patch the DLL file and increase our speed. I'll just use the search feature to search for sprint in all the fields to see if we can find something and permanently increase our game speed. After our search, we come across an interesting function that is getSprintMultiplier. This is into the namespace of our player, so that's why it is interesting. Once we click on it, we can simply get down here. As we can see, in the sprint multiplier, there is a static variable declared here. By clicking on it, we can simply navigate to the address where this variable is declared. Now, if we check the value of this particular number into the hex converter, we can see that the little endian value of this is a float 3. So we can assume that float 3 is the sprint multiplier of our game at the moment. Now let's open a hex editor to edit this particular value to something more. We will try to change this particular value, so instead of 3, it becomes higher than that. Let's see if we can change it to around 12. For changing it, we can simply use this particular value and this will give us the sprint multiplier of 4. So like the value of our player's speed becomes 4 times more than it originally was, essentially quadrupling the value of our player. Now to patch this particular variable, we turn to any hex editor. In this video, we'll be using Binary Ninja. With the hex editor, we will locate gamelogic.dll and start our quest to modify the sprint multiplier. So let me just open Binary Ninja. Binary Ninja is a great tool for editing DLL file and doing dirty patching. So make sure that once you have opened the gamelogic.dll file, you set the view as hex editor. Now we will try to search for that particular variable that we have found in Ghidra, that is the sprint multiplier. The static variable is particularly declared here, and we can see that the instruction for it 00004040. We'll just copy this particular value and try to search it in the binary ninja. In order to search it, we can simply go to File and then Edit, then select Find. Make sure that you change the find type to hex string, as this is a hex value. After searching for it, we come across two different values. One is particularly at this address and the other one is around here. To make sure that we are using the current value, let's check out Ghidra to see other values as well. So as you can see that there is 2040 and then 004040. Now let's open binary ninja and try to find that particular variable. As you can see that this particular value matches the value of our static variable. Now we'll try to patch it by entering 41 and 41. In order to edit the hex values of the DLL, we must unlock it first in binary ninja. As you can see by clicking on this button, we are unlocking the file to allow changes. Once the file is unlocked, we'll simply replace this particular value to 4141. This will essentially change the float value of the sprint multiplier from 3 to around 12, essentially quadrupling our speed. Once the value is changed, we can simply press Ctrl S in order to save the file. Because our game is opened right now, it will be impossible for Binary Ninja to save it in the same file. So I'll just change the name from gamelogic.dll to gamelogic_edit.dll. As you can see, we have replaced the original gamelogic.dll with our edited gamelogic.dll file. Now let's open the game. With the new DLL in place, we launch the game and we can observe that the speed hack is working. So far, we have done static variable patching. Now let's move on to more complex challenges. The next thing we can patch is the value of variable to extend our jump hold time, enabling us to glide in the game without depending on cheat engine or any other tool. So far, we have done static variable patching and now we are moving on to more complex challenges. The next thing we can patch is the value of the variable to extend our jump hold time, enabling us to glide in game without depending on cheat engine or any other tool. So let's open Ghidra and search for jump. As we know that the jump hold value was very less because we manipulated it earlier with cheat engine, we know that there is a particular function known as getJumpHoldTime which we intend to patch through binary patching by using Binary Ninja. We are not dealing with a static variable this time. Our goal is to modify the jump hold time to match the jump speed and set the value of both variable to 420. We know that the value of jump speed is 420 because we earlier manipulated it with the help of cheat engine. We need to find specific instructions responsible for jump hold time, and we can see the instructions for jump speed. The strategy here is to change the instructions of jump hold time to match with the instruction of jumping speed, giving us the value of jump hold time as 420. We find the specific instructions responsible for jump hold time and we make the necessary changes, and the jump hold time value will be picked up from the value of jump speed, that is 420. So let's open Binary Ninja and replace this value with this particular value. I'll simply go on edit and then I'll select find Make sure that the find type is selected as hex string. Copy the instructions from jump hold time. We just need to replace the 28 with 24. Let's change it. As we can see, this is the instruction for getting jumping speed, and this is the instruction for getting jump hold time. So we'll just edit this particular value. And now you can see that the jump hold time value will be equal to the jumping speed, and that is 420. And let's save our edited DLL file. Now we'll need to restart the game and see if it works. As of now, we have successfully edited GameLogic.dll file to change and manipulate the value of our player's walking speed and the jump hold time. The cool thing about this is that we have edited the DLL file and modded the game itself. We are not dependent on any other third-party tool to edit the value or anything else. This is how modded games usually function. As we navigate along in the island, we end up at a new location, that is Gold Farm. Interacting with the NPC starts our second quest. The farmer is looking for cows, which are lost. As we don't have any other information at that moment, let's search for the term cow in Ghidra to gather information about the location of the cows. Okay, there are a lot of cows. The search term for cow results in interesting results. We find a location named Cow Bungalows. So, the search term for cow results in cow level destination. And we also come across a particular destination that is cow level. And then there are something mentioned about fast travel destinations. By looking at these strings that are referenced in Ghidra, it seems like they are the identifiers for places in the game world. It might mean that we can use them to teleport to those places. And when we talked with the farmer, he also mentioned something about teleporting. So that can be a hint. Because we have explored a game a little, we already know that there is a built-in fast travel system within the game that allows us to teleport in a new locations. Next, let's search for fast travel in Ghidra. After searching for fast travels on Ghidra, we find a lot of interesting entries. One interesting thing is get fast travel destination, that is in the player's namespace. Let's copy this particular offset and look it into the memory viewer of Cheat Engine. When we have a closer look at Get Fast Travel Destination, we find a reference to Unbearable Woods, and then Town, and other locations. such as Tail Mountains, etc. In simpler terms, there's a part in the game where a value 0xf is used. This value is like a code, it represents a number. For example, with unvariable votes, you can see 15. And when we check out town, we can see 4. This particular value represents the length of the location. For example, if we check out this particular function in the compiler, we can also see that there is a check of the length of location. So this particular value is checking the length of the location town, that is around 4. So if we are replacing this particular location, we will also have to replace this particular value. That would be the length of this location here. So let's try to replace town with the destination that we found earlier. Now we want to change this and make it to go to a different place with a longer name, that is cow level. Instead of town, we want our player to travel to the location that we found earlier, which was cow level. So basically, we want to replace this particular value with cow level and this particular value with the length of our destination. Let's make the changes. Make sure to note the offsets of these locations as we will use it in future for DLL injection. We found out that this cow level destination is with the name cow level and it's declared at this particular offset. Let's copy this particular offset and change the value of town with logic.dll plus the offset. As you can see, the comment value is changed to cow level. So that means we are on the right offset. And now let's also change this particular value that does a comparison check of the length of the destination. So there are total 8 letters in the string cow level. So we will replace push 04 with push 08. If everything has worked successfully, when we choose to travel to town, we shall see cow bungalow instead. Now our fast travel selection for town is now replaced with the location cow bungalow. So now when I'll select this entry, I shall be transported to cow bungalows. And here we are. It looks like a hidden location that was not on the maps. And as you can see, we have been teleported to cow bungalows. Let's explore this particular island. It looks like I'm able to kill the cow. So let's see what this area is. Hello, welcome to my humble bungalow. I was enjoying my private island until those mad cows showed up. Where did the cows come from? They had a thunderous boom, and when I looked outside, there were mad cows everywhere. There is one particular that worries me, and that sounds fun. The one with the crown. I think that gets close to it, struck by a bolt of lightning. Do you know any magic? I do. Why do you ask? I have a legendary magical cube. I read that it possesses the power of the fabled cubic and might be able to steal the thunder of the Cow King, leaving it defenseless. I would, but I'm terrible with my magic. My last attempts got me strong. Okay, so I'll just use it. I'll take it. Thank you. Cool. Now we have acquired a new weapon, as you can see. Let's go towards the Cow King. That was killing us. Yeah, this one. we have acquired a new weapon, that is static link, and we died. Okay. Now we have different weapons. We have a cube and we have static link. This was the weapon of our Mad Cow King. Now let's see if we can use it. Oh, okay. As you can see, we have completed the second quest, and the name of the quest was Until the Cows Come Home. We have acquired the flag of the cow now, and that's great. For sake of understanding, I also wanted to show you guys how you can achieve this by using DLL Injection. Because a lot of times, you don't have the time to just open Seed Engine and edit something, especially when you're playing an online game. So DLL Injection can be super useful for just writing your own code and running it, and then making changes within the game in order to activate or deactivate your hacks and do some more complex tasks. So far we have learned how to edit static variable and dynamic variables and patch the binary. We have used Binary Ninja in order to edit the game logic.dll to mod the game permanently and give us high speed and higher jump hold time. Along the way, we have also solved another quest, that was the flag of the cow, and it was a pretty interesting quest. We also managed to get a new flag, that was the flag of the cow, and we also solved the second quest. However, there is one more thing that we have yet to learn, and that is DLL Injection. So let's see how we can solve the same challenge with the help of DLL Injection. We already know the offsets of the locations, all thanks to Ghidra. Now we'll try to write a DLL file that, once injected inside the game, will give us the ability to change the value of the locations by simply using a keystroke while playing the game. The reason that learning DLL Injection is so important is because it allows us to change and manipulate the value, do custom and complex tasks while playing the game itself. So let's see how we can write a DLL and inject it into the game. We will simply restart the game and cheat engine to reset the values and changes we made through the cheat engine. Now we'll open Visual Studio in order to create a DLL that we can inject using cheat engine or any other DLL injector. If you're wondering how the trainers of a game is made, basically, hackers write a code that can be injected into the game's process, which will run within the space of the game and help the hackers in manipulating the values and memory addresses of the game, completely changing the logic of the game. So let's open Visual Studio and create a new project for our DLL. One thing to note here is that we are using Visual Studio. Please don't confuse it with VS Code or Visual Studio Code. While creating a new project, you can simply search for templates and search for DLLs. Once you create a new project, make sure that you change the build architect target type to x86. That's because the game is 32-bit x86 based architecture and we want to build our DLL to work on the same. After setting up a new project and changing the build type, let's start by importing the necessary libraries that we will be using. To start, let's take a look at libraries we are working with. We are using Windows.h and DLL32.h for interacting with the Windows API. These libraries allows us to manipulate memory, capture processes, snapshots, and load modules within a process. We have also imported basic C++ standard libraries like IOStream for console output and Vector for handling dynamic arrays in the memory. We will be using dynamic memory for manipulating offsets. Now first of all, let's design a function that will take the module's base address that we will be injecting in. One of the key part of this code is the getModule base address function. This takes the process ID and the name of a module. In our case, the name of the module is gamelogic.dll. Here's how it works. We create a snapshot of all modules loaded into the process using createToolHelp32 snapshot. We then iterate through the snapshot using module 32 first and module 32 next, comparing the module name until we find the one that we want. Once we get the match, we grab the base address of that particular module. This base address will allow us to manipulate the memory for a specific module, which in this case is a part of the game we want to have. Now we need a function for patching the memory addresses. So let's create a function patching memory. This is where the magic happens. Once we get the base address of the game module, we need to modify its memory. The function takes a destination pointer, a source pointer, and the size of the memory block we want to change. First, we use virtual protect to set the memory protection so that it can be written to. We then copy the new bytes over using memcopy and finally restore the original protection. This means we can seamlessly alter game's code or data and patch the values. Next, we'll need a function that will resolve the pointer chain and locate the values that we want to edit by using different pointers. This function helps us to access specific part of the game's memory that are located through multiple pointers. This is really useful when working with complex games that store data in the structure with many layers of indirection. We pass a base address and a series of offset to navigate through these layers. The function returns the final resolved address, allowing us to modify and read values from deeply nested memory structures. Now let's get into the main part of the hack. The function execute hacks. This function contains the core logic that modifies the game behavior. First, we grab the current process ID with the getCurrentProcessID function and then get the base address of the game logic DLL using our earlier function. Once we have the address, we can resolve the memory location of a specific game feature we want to modify. In this case, it's two features. We have named Cow Bungalow address and Unbearable Forest address that we have noted previously. These offsets have the value of these locations. To interact with the game, we open a console using allo console to output debug information and monitor our game hack DLL. The hack itself is activated when the user presses the right shift. We have used vk-rshift function to toggle our hack. This basically replaces the values of these memory locations. When right shift is pressed, we use the patch memory function to change the game logic, swapping in the new values and changing the game's behavior on the fly. Now we just need a DLL main function so that whenever the DLL is injected, this function is called. In our case here, we are creating a new thread to run execute hacks function. This allows the hack to run in parallel with the game, continuously monitoring for the key press and applying memory patches as it detects the right key shift is pressed or not. This technique is a core part of DLL injection, where we load a dynamic library into a game process and manipulate it from within. DLL injection allows real-time manipulation of the game memory. Now let's try it out. Now we are good to go, so let's test the code. First of all, in order to build this DLL, you simply need to click on build. Just make sure that the architecture is correct and is set to 32-bit because our game is of 32 bits. So I'll just build the solution. Once the solution starts building, you can see if there are any errors in the console. Along with that, you can also see the DLL file and where it's at. So we know that our DLL has been compiled without any errors. Now let's test it out. We need to inject this DLL, and to inject the DLL into the game's process, we will be using Cheat Engine. In order to inject the DLL by using cheat engine, we can simply load the cheat engine and attach it with the game's process. Click on Memory View, click on Tools, and select Inject DLL. Once the DLL is injected, cheat engine by default asks you that if you want to execute a function of the DLL. Right now we don't, so we'll just select No. Since we have set our function to execute on the right shift key press, we will not execute any functions after injecting our DLL through cheat engine. As you can see, our DLL is successfully injected and we are seeing the standard output into the console along with the process ID. Right now I haven't pressed a key while playing the game, so we are still seeing unbearable words. Now let's see if we can change it by pressing the right shift key. As you can see, our DLL injection is working pretty fine and we just don't need to use any other tools, and we can simply use the keystrokes in order to enable or disable the cheat. And that's a wrap, guys. From unbearable revenge to the flag of the cow, we have explored different techniques of game hacking. This includes binary patching, DLL injection, using tools like Ghidra, cheat engine, and Visual Studio. Today we level up by creating our internal hack with a dynamic link library. We tweaked the game logic, mastered player coordinates, hacked the fast travel feature. If you enjoyed this video and learned something new, don't forget to give it a thumbs up and subscribe. And share it with your friends. If you're interested in hacking, sign up on Bugcrowd at bugcrowd.com/hackers. Thanks a lot and see you next time.